All right, question number 7 on supplement C involves something, mainly a business application. It's something referred to as the cost function. And here's the basic data that's going on. We're being told that it costs $15,000 to produce 20 computers, and we're being told that the fixed costs are $2,500. Okay? Now, part A, which asks you to actually graph the function, I'm not interested in. Now, if you're in my 1105 class, I'm never going to be interested in part A. I don't care about you graphing this function. If you're in somebody else's 1105 and you're watching my videos, you need to ask that teacher whether or not he or she wants you to do part A. If they do, they better show you how to do it, okay? In fact, they don't even put it on the departmental key, so the department doesn't seem too interested in it. But you should always check with your own instructor if I'm not your teacher, okay? But I'm omitting part A. Part B says, determine the cost function. Determine C of X. Now, what's actually going on here? And of course, we know this is MX plus B. Determine the cost function. C is cost, and X is the number of computers that we're producing. So here's your legend. Cost comes out, X goes in. The number of computers goes in, the cost comes out. So if I say I'm producing 20 computers at a cost of $15,000, that would be the ordered pair 20, 15,000. You with me? Okay. Number of computers goes in, cost comes out. The fixed costs are $2,500. What fixed costs really mean is, if you produce zero computers, you're still going to have a cost of $2,500, you know, for your building, for overhead, for something. So anytime you see fixed costs, zero computers are still going to cost you $2,500. Now, there is a perk to this. The perk is, since this is zero, you just got B. So they threw you B. B is 2,500. So that's nice. So all we have to do now is find slope. And to find slope, the change in C divided by the change in X. Okay? Change in cost divided by the change in the number of computers we're producing. Okay? To get the change in C, I subtract, and I do the same to get the change in X. When I look up here, I'm going to take 15,000. Doesn't matter which Y value I start with, but I'll start with that one. 15,000 minus 2,500, and then 20 minus 0. So, I'm going to go ahead and calculate what this number would be. And let me grab my calculator here and punch it in, turn it on, clear it out. I'm going to type left paren 15,000 minus 2,500 right paren divided by left paren 20 minus 0 right paren, and hit enter, and I get the answer 625. So, C of X is equal to 625X plus 2,500. This is referred to as my cost function. Okay? Let me write it again on the back page. Okay, so my answer to part B, C of X, the cost to produce X computers, is 625X plus 2,500. Okay, that is the answer to part B. That is my cost function. Part C, the question asks this. Let me find it. What is the total cost to produce 12 computers? Okay, well that's easy. We just put in a 12. we find C of 12. 12 is the number of computers. We're finding the cost. 625 times 12 plus 2,500. And when I punch that into my calculator, I come out with $10,000. So that is the cost to produce 12 computers. And part D of this problem asks, let's see, what does it say? What is the cost to produce each additional computer? Okay. The answer to that problem, what is the cost to produce each additional computer, is $625. And basically what they're trying to get you to see here is this. In the cost function, since this is a linear function, the slope has a particular meaning. 625 for the slope is really 625 over 1. So what that's saying is, for every one additional computer, you're spending $625 more in cost to produce it. So the answer is 625. So what they were really trying to get you to understand in part D, that in this cost function, it's a linear function, the slope is actually the cost to produce one more computer. And that's because 625 is 625 over 1. $625 to produce one additional computer, or each additional one. Okay? And we're done.